So when we find surface area of modified shapes, we do not actually change the formula that we are using for surface area. Okay, the surface area formula is always going to be the same. That is 2 areas of the base plus the perimeter of the base times the height. So we're not actually modifying our formula here. We are using the same old surface area formula that we've always used. The only thing is we are having a base that is modified. So our base is this square, 10 by 10 square, that has a circle cut out of it. So when we find the base area, we're going to have to do a subtraction problem. So the base area is a square minus a circle. We have less area for your base. So our square is 10 squared minus pi times 3 squared, which is 100 minus 9 pi, which as a decimal becomes 71.72 square centimeters is the area of your base. That is the square's area minus the circle's area. Now, funny thing about the perimeter. The perimeter of your base is the square, of course, on the outside, but the perimeter is the tangible edge. And it turns out that when you cut holes in things, you have more edges. So now we can touch this circle and run our finger around it, so we have more perimeter when we have a modified surface. We have less area, but we have more perimeter. So it's a square's perimeter outer plus the circle's perimeter. So we subtract for base area, but we add for perimeter. So perimeter of a square is 10 times the sides. Perimeter of a circle is 2 times pi times the radius. So we have a perimeter of 40 plus 6 pi, which as a decimal approximation becomes 58.85. Centimeters is the distance of all of the tangible edges of this modified base. So now that I have all that information, I can go into my surface area formula. 2 times the area of the base, which was 71.72, plus the perimeter of the base, which was 58.85. Sorry, I'm running into it. And the height is 8. The height is the distance in between your bases. Okay? Now all this goes into your calculator, and that gives us a total surface area of 614.25 square centimeters. That takes into account every single one of the surfaces, so we don't have to add them up separately.